Hi everyone, you're halfway through the take-home unit, Unit 7. Today we're going to talk about some properties of graphs and equations. Your aim today is that I know how to determine if an XY pair will make an equation or system of equations true or untrue. So we're going to talk about the truth of graphs. Okay, so at this point we've looked at graphs of linear functions and more general functions as simply being plots of input and output pairs, right? We find the x, we get the y, we make a point. And for functions, this makes a lot of sense. But more generally, we want to be able to define points that lie on the graph of an equation or an inequality with a simple test or definition. So here's our definition. The connection between graphs and inequations and inequalities is a simple one. Any coordinate pair xy that makes an equation or inequality true must lie on the graph. So if you plug in x and you get y, that must be a point that lies on the graph. The entire graph is the collection of all the xy pairs that make the equation true. So the picture of a graph is a series of all of the points that when you plug in one point, when you plug in the x, you get the y. So exercise 1, let's take a look at this idea of truth. Consider the linear equation y equals 4x plus 2. So here's our equation they give us. Does the point 2, 10 lie on the graph? For something to lie on the graph, it has to be true. So this question is basically saying, hey, look, plug in 2 for x and 10 for y and see if it works. So that's what I'm going to do. So I'm going to rewrite my equation. Y equals 4x plus 2, but instead of a y, I'm going to plug in a 10. And instead of an x, I'm going to plug in a 2. And now I'm going to see if it's true. Does 10 equal 4 times 2 is 8? And is 8 plus 2 10? Yes. So this point does lie on the graph. Yes. 2, 10 lies on the graph because it makes the equation true. I got 10 on both sides when I put in the two values for x and y. Okay? If you want to pause and try letter B on your own, please do so. B is very similar to A. You're just now seeing if the point -1, 4 lies on the graph. So if you want to pause and try on your own, please go for it. Okay? So we're going to plug in -1 for x and 4 for y. So same equation, y equals 4x plus 2, but now instead of y, I'm going to plug in 4, and instead of x, I'm going to plug in -1. When I simplify, I get 4 equals 4 times -1 is -4, and -4 plus 2 is -2, so no, these two things don't make the equation true. So the answer to this is no, -1, 4 does not lie on the graph because it does not make the equation true. Okay, so a basic principle here, if the point makes the equation true, it's on the graph. If the point is on the graph, it makes the equation true. So both of those things go together. Okay? Next exercise, the equation y equals 2x squared minus x plus 5 describes a parabola. So parabola is a word we're going to talk about a lot in trimester 3, but for now, know that the general shape of a parabola looks like this, or it looks like this. That's a parabola. It's either an up curve or a down curve. Okay? So this question is saying, does the point 320 lie on its graph? Okay, now there's two ways to do this. If you were in class right now and not at home, you could plug this equation into your calculator and see if the point 320 is on the table. But we can also plug in the point 320 into this equation and see if it works. So I'm going to label my point. This is the x and this is the y. So my equation, y equals 2x squared, minus x plus 5, and I'm going to plug in the point 3, 20. This is the x, this is the y. So instead of a y, I'm going to plug in 20, and instead of the x, I'm going to plug in 3. I'm going to use parentheses to plug in 3, so I'm really careful with my signs. You always want to use parentheses when you're dealing with exponents because if you got negative things you're plugging in, and negative 3 squared is very different than parentheses negative 3 squared, so you've got to be really careful. So I'm going to use parentheses. Now I'm going to simplify. This becomes 2 times 9, because 3 squared is 9. This becomes minus 3 plus 5. 2 times 9 is 18. 18 minus 3 is 15. And look at that, 15 plus 5 is 20. So I found out that yes, the point 320 lies on the graph because it makes the equation true. Now, it doesn't matter to me how you would do this on your fluency with the table or by algebraically by plugging it in. On the Regents, though, they might say show algebraically that it's a point, in which case this is algebraically. Right? You're showing your work, you're using numbers. This is algebraically. Okay? So we're basically plugging in points, seeing if it works to find the truth of lying on the graph. Okay? Exercise 3, now we're going to take this same idea and talk about inequalities. So inequalities can also be graphed, and we're going to talk about that on the last lesson, is graphing inequalities. But for now, let's talk about if certain particular points will lie on the graph of the inequality, even before we actually graph it. So exercise 3 says, determine for each of the following inequalities whether the point given lies on the graph. So the idea is the same, except you have to remember what these things mean. And I'll write on the top here. Remember that this is less than or equal to, this is greater than, and this is greater than or equal to. You have to memorize this, because that's how we have to read these inequality statements. Right? It's no longer just equals. We have to actually think about less than or greater than. So the idea is the same. We're still going to plug in this x and y. So 4 is my x, 1 is my y. So I'm going to have, instead of y is greater than, I'm going to have 1 greater than 2 times 4 minus 5. So I'm basically plugging these things in. Determine for each whether the point lies on the graph. So we're plugging in the points. Now I'm going to simplify. On the left I keep my 1. On the right, 2 times 4 is 8. And 8 minus 5 is 3. Now you have to ask yourself, is 1 greater than 3? No. 1 is not greater than 3. So this is not a point on the graph. Okay? That's not true. Let's try the next one. Okay, I'm going to label this my x and my y and see if it lies on the graph. Instead of x, I'm going to plug in 2. Instead of y, I'm going to plug in 8. And now I'm going to simplify. 2 plus 8 is 10. Is 10 less than or equal to 10? Yes. So it lies on the graph. Okay. You can try the next two on your own if you want to pause and try. Remember to simplify correctly. Be very careful with your signs and how you read your inequalities. Okay. Letter C. Negative 3 is my x and 2 is my y. So instead of a y, I'm going to plug in 2. And instead of an x, I'm going to plug in negative 3, and I'm going to use parentheses because I'm going to be very careful. Carry down the 2. Negative 3 squared. I'll write it down here. Negative 3 squared is the same thing as negative 3 times negative 3, which is going to be positive 9. So this becomes positive 9 minus 4. And is 2 less than 5? No. So does not lie on the graph. Okay. And finally, letter D. Negative 6 is my x and negative 1 is my y. Oh, I made a mistake back here, actually. 2 is less than 5. See how easy it is to make a mistake? The number 2 is less than 5. I'm going to write it out. Is 2 less than 5? Yes. So this does lie on the graph. Sorry about that. Okay. All right. Next one. Negative 6 is x and negative 1 is y. So I'm going to plug in negative 1 on the left, greater than or equal to, x is negative 6. So I'm plugging that in for x. So I get negative 6 plus 12 over 3. This becomes a 6 on the top. Negative 6 plus 12 is 6 divided by 3. And I get negative 1 is greater than or equal to 2. That is not true. Negative 1 is not greater than or equal to 2. So this does not lie on the graph. Okay? So the overall lesson here is that if the point satisfies the equation, it's on the graph. If the point doesn't satisfy the equation, then it's not part of the graph. We don't have to graph these to even determine that. We can determine it algebraically by plugging in the values and seeing if it's true. Okay? Now let's go to another idea here. We've talked about now just simple equations, we've talked about equalities, but now let's talk about what happens when we have a system. So we can even determine with some additional calculations whether a point's a solution to a system of equations or a system of inequalities. You've studied systems before in 8th grade, and we're going to devote, Unit 8 talks a lot about systems. So we're going to get a little head start here on this lesson right now. So a system of equation is a collection of two or more equations joined by an and truth condition. Because the and condition is only true in all of its components true, the solution set of a system is the collection of all points that result in all equations being true. In other words, this is really saying that both equations must be true for it to be a point on the graph. Okay, they both have to be true. That's what this and statement is. And we worked with these and or statements in Unit 4. And a lot of students didn't get to Unit 4, which I think was something this might be a little new idea here, but this and means that both equations have to be true. So let's take a little example of what this means. So exercise 4, this is a system right here. I've got this first equation right here and this second equation. This is called a system. Okay, a system has two equations in it. And now this question is saying, is the point 3, 1 a solution to this system? In order for it to be a solution, it must work in both equations. So I'm going to rewrite both equations here. I'm going to rewrite one in green, and I'm going to rewrite one in purple. Okay. So let's do the green one first. I'm going to take the green one, I'm going to rewrite it. Y equals 2x minus 5. And notice, what am I plugging in now for x? I'm plugging in 3 for x and y, 1 for y. So I'm going to have 1 equals 2 times 3. Remember, I'm plugging in the 1 and the 3 from up here. So I'm coming from up here and I'm plugging in. Okay, now I simplify. 2 times 3 is 6. And 6 minus 5 is 1. So it's true for this one. So the first equation is good. But because this is a system, this point will only work if it's also true on the other equation. So I'm going to go to my other equation. So now I'm going to write my other equation. Y equals negative 4x plus 13. And I'm going to plug in 3 and 1 again. So 1 for y and 3 in for x. And I'm going to simplify. 1 equals negative 12. Negative 4 times 3 is 12, plus 13, and negative 12 plus 13 is 1, so it's also true. So my answer to this question is yes. 3, 1 is a point on this system. It is a solution. Okay? Because the point is true for both equations, it's true for the entire system. Okay? Now, it's important to keep in mind that most of the time the word and will not be included as it was above. So see how this says and right here? Usually that won't be there. Usually it'll just have the two equations right next to each other, and that'll be called a system. So the assumption will be that by telling you it's a system, you automatically know that the and is just automatic. It's like knowing that there's always a plus sign in front of a number even if there's not one. So exercise 5 now is saying, does the point 515 lie in the solution set of the system of inequalities? So the same exact idea, except now we have inequalities. but we solve it the same way. I'm going to make the first equation green, like I did last time, and the second equation purple, and what are we going to do with this 0.515? We're going to take this 0.515 and we're going to plug it in. Alright, so here's my green equation. Y greater than 4x minus 7, but now instead of y and x, I'm going to plug in the 15, and I'm going to plug in the 5 from my point and see if it works. Keeping in mind that this is a greater than symbol. So I have 15 greater than or equal to, 5 times 4 is 20, and then I bring down the 7. 15 greater than or equal to 20 minus 7 is 13. Is 15 greater than or equal to 13? Yes. So this one is true. Now let's try the purple one. I'm going to rewrite it over here. This is now a less than symbol, but same idea. What am I plugging in? The 5 and the 15. So 15 in for y. Oops. 15 in for y and 5 in for x. Remember to use my parentheses. 5 squared is 25, and 25 minus 10 is 15. Is 15 less than 15? No, it's not. It would have to be less than or equal to, but this doesn't have an equal to, so no, not true. So the answer to this question is no. 515 is not part of the solution set because it didn't work for both. It has to work for both for it to be true for a system. Okay? Alright, last exercise says you can even mix equations and inequalities. So in this oh sorry, I don't know why this is here. The saving ink notes is here. I'm sorry guys, and I'm not really sure why that's doing there. Just ignore it. So this problem says you can mix an equation. So here's my equation, the green one, and you can mix an inequality. Well, this is my inequality, the top one. One has an inequality sign and one has an equation. The same principle holds true. Is the point a solution to this system? We do the exact same thing. We plug it in and see if it works. So x is -2 and y is 5, and we're going to plug them in. So I'm going to do the purple equation first. I'm going to write it down here. Y greater than 4 minus x over 2. But I'm going to now plug in the 5 and the -2. So instead of y, I'm going to have 5. And instead of x, I'm going to have a -2. I'm using parentheses because 2 has a negative and the equation has a negative. So I have to have two negatives. So be really careful there. Bring down the 5. 4 minus -2 becomes 4 plus 2. 4 plus 2 is 6. And 6 divided by 2 is 3. Is 5 greater than 3? Yes. It is true. So it works for the purple equation. Alright, now let's try the green one. So now I have y equals 3x plus 11. Going back up here, I'm plugging in -2 and 5. So I plug in 5 for y, and I plug in -2 for x. And now I simplify. 5 equals 3 times -2 is -6. Carry down the 11. -6 plus 11 is 5. Does 5 equal 5? Yes. It is true. And what does it tell us if both are true? Yes. The point -2, 5 is a solution. Okay, so the whole objective of this lesson is to show you that you can determine if points are on the graph of an equation or a system just by plugging in the x and y values. I think this is really good practice for your algebra skills while you're at home. Feel free to use a calculator online on the internet to check your work on your fluency. And if you have any questions, please don't hesitate to reach out. You've got one more lesson left before the unit is finished and you can think about your take-home exam. Also, you can work on your take-home exam in between lessons. So if you did lesson 1, 2, and 3 right now, you can go look through the take-home exam and see if there are questions you could answer. You don't have to wait and do the take-home exam right after all of these 4 lessons. You can go back right? It's a take-home exam, so use your resources, use your notes, use what you have to help you. Okay? You've got one more lesson after this. Good luck.